So 4F is about function notation. We've already talked a bit about function notation with this stuff. Alright, now this doesn't look like what we looked at last time, but we did talk about this being the domain and this being the codomain and this being the function. Yes, it is a y. It's a numpty y, but it is a y. Okay. So this is about domain and range and all that sort of stuff again. Okay. It's also about substituting things in. Okay. So fx. Okay. So if fx, let's just make one up, equals 3x squared plus 2x plus 5. Okay. If that's fx, if I'm given a job to do and it says f2, okay, all you need to do is swap the x's for 2's. That's it. So it's 2 squared plus 2 times 2 plus 5. So, and then you work out the answer and it's what, 12, 16, 21 I think. That could be wrong, could be right, who knows. But it comes out at a value. Okay, so have I done that right? No, I haven't. So let's choose a different fx for this next section. Fx equals 2x plus 5. Let's do a real simple one. Okay, real simple one. And then you get, okay, so you've got f2 is evaluate that polynomial when x is 2. Okay, if you have fx equals 9, okay, that's telling you to do something different. Okay, x is 2, alright. How did you work it out?
2 times 2 plus 4.
Right, yeah. But what you actually do, mathematically speaking, is you do this. The whole thing, 9 equals 2x plus 5, right? Because the function is 9. The whole function equals 9. So you change the fx for 9, then you move the 5 over, you end up with 4 equals 2x. Yep, and then x equals 2. Alright, that's the whole goal there. So they're the two different things. If it's inside the brackets, then you're substituting it in. Okay. If it's the function equals, then you're trying to rearrange to find x. Now that could be rearranging to find the x-intercepts of a cubic or a quartic or a quadratic. Okay, so all the stuff we've talked about is going to come into here as well. But you just need to know that you're talking domain, codomain, and your function, and then you can do these things with your functions. Alright? So a couple of examples here. We'll do question 4b, which is y equals the square root of x minus 6. Alright? In that question we're being asked to fully define that in the fx, f dot dot x to y comma fx. Right? X minus 6, that's an x. Okay? So we've got to put it in that format. Okay, is that better? Alright, so I've got to put it in that format. So f dot dot, and this is where it can be tricky, and this is where you need to switch on your brains and think about it. X was what? What was that big X there? Domain. So what X values can I substitute into this equation? Okay, because there are some I cannot substitute in. If I've got a square root, can I square root a negative number?
No.
No. So I cannot put x's in that are going to make this underneath the brackets negative. So I can't put 5 in.
It's going to be 6 or higher.
So it's got to be greater than 6. Can it be 6?
No.
Yes, it can.
Yes.
Can't it? 'Cause
Yeah.
0, 0, 0.
So if it's going to be 6 or higher, then I can do including 6 to infinity.
Oh,
Okay, so that's my domain. So it can't be lower than 6, because if you take 6 from 5 and it with negative 1, and we can't square root that. So straight away our rule is broken. We can't do it. So our codomain normally is what?
No numbers.
Normally it's real. Okay? Unless it's a discrete function, like unless it's discrete points that you're substituting in, it's normally a real number. And my rule is fx equals square root x minus 6. Alright? That's as easy as it gets. Okay? The trickiest part of this is working out your domain. Okay? Because you need to put on your brain and work out what numbers can't it be, and therefore you can work out what numbers you can put in your domain. Sorry? What if it's a positive number? What do you mean?
The -6.
Like the -6 plus 6.
Then it's going to have to be, if it, so if it was y equals square root x plus 6,
Yeah.
then you can't be
Below -6.
below -6. So you would, and you can be -6, so your domain, you would be from -6 to infinity. Right? So it doesn't change it overly much. Alright. Now if you want, you can relate that to what the graph actually looks like. Okay, and this is something I just came up with off the top of my head right now. What's the graph of this one look like? Right, it's standard graph is that. What's next? What have I got to do to it? What's this telling me to do?
That's telling me to move it around 6.
So we're starting here. Can I be anything below here? No, because my graph doesn't exist. Alright, and relate that to this one as well. So this one has moved, so it's standard like that, it's actually moved -6, so I can't be anything that way. I've got to be this way only. Okay, so if you relate it to the graphs, that might help also. Okay, so question 5b is sort of going the other way. Okay, so they've fully defined the function for you. They're asking you to tell the domain, the codomain, and then the range. And it's the range that gets tricky. Okay, so the domain is easy. There's this guy here. Domain is between 0 and 10. Okay, including 10 but not including 0. Your codomain, super easy. It's this guy here. It's real numbers. Okay, but where in there does it define your range? And the answer is it doesn't. Okay, you need to work it out. All right, unfortunately, you need to work it out. Okay, so how are we going to work out the range? How are we going to work it out? What's the range? Tell me again what it is.
What x would be?
No, that's domain.
What y can be?
What y can be is our range. So if we have a look at this graph, we're doing a 3 on square root x graph. Okay, so if we again relate it to the graphs that we've done, what's that look like?
That's a hyperbola.
A truncus.
No, it's it's hyperbola. Sorry, I had to get my head around which one it was. So it looks like that, doesn't it?
Yes.
Right. But we're only doing it between 0 and 10. So we can forget this half of the graph straight away. Okay, it's only on this side and it's only up to 10. Okay. So what do you think our range will be? The closer I get to 0, what's my y value?
The higher it gets.
Yeah. So what do we call that when it keeps going and on and on? Infinity. So we're going towards positive infinity. Okay. The closer we get to 0. What are we at here? How do I work this out? How can I work out if that's the point I'm including 10, so I should really have a closed dot there. How do I work out what that x value, sorry, what that,
Substitute that in for the y.
right, you substitute, no, you're substituting the x in. I'm trying to find the y value.
X in for the y as well.
X in for, to get the y?
Yeah.
Yes, so be careful the way you're saying that, alright, that leads to confusion. So if we say y equals 3 on square root 10, okay, that's what that is. And I'm pretty sure that's how they left it in the book. Alright, so your range, so you should write range of g equals, okay, 3 on square root 10 inclusive to infinity. Now do I include or do I not include? You never include infinity. Infinity always has the circular bracket. Okay, so domain and codomain are easy. Range you have to work out for yourself, and I think personally the easiest way to do that is to sort of do a bit of a sketch and work out what you're looking at.